dear students. Today we shall study about the concept of oxidation number in redox reactions. So the objectives of today's lesson are to calculate the oxidation number and to use the concept of oxidation number to identify oxidizing agent and reducing agent in a reaction. So first, let us understand what is oxidation number. Oxidation number denotes the oxidation state of an element in a compound ascertained according to a set of rules formulated on the basis that electron pair in a covalent bond belongs entirely to the more electronegative element. Let us take an example, HCl, where there is a covalent bond. So when we want to determine the oxidation number, we will give +1 to hydrogen and -1 to chlorine, because chlorine is more electronegative than hydrogen. Let us discuss the rules to find out oxidation number. The first one, in elements in the free or the uncombined state or in any allotropic forms, each atom bears an oxidation number of 0. So each atom in H2, O2, Cl2, ozone, P4, S8, sodium, magnesium, aluminium has the oxidation number 0. Next, for ions composed of only one atom, the oxidation number is equal to the charge on the ion. So let us take examples. Oxidation number of K plus is +1. Oxidation number in case of Ca2 plus ion is +2. Fe3 plus ion is +3. In case of negative ions like Cl minus, the oxidation number of Cl minus ion is -1. O2 minus oxide ion is -2. All alkali metals, lithium, sodium, potassium, rubidium, cesium have oxidation number +1 in their compounds. Similarly, all alkaline earth metals, beryllium, magnesium, calcium, strontium, barium have oxidation number of +2 in their compounds. Aluminium has an oxidation number of +3 in all its compounds. The oxidation number of oxygen in most compounds is -2. So we should remember what are the exceptions. The exceptions are in peroxides and superoxides. In peroxides like hydrogen peroxide, H2O2, sodium peroxide, Na2O2, each oxygen atom is assigned an oxidation number of -1. So in case of H2O2, each hydrogen atom will have the oxidation number +1 and each oxygen will have the oxidation number -1. In superoxides like KO2, RbO2, each oxygen atom is assigned an oxidation number of -1/2. So let us take example of potassium superoxide KO2. So potassium will be +1 and each oxygen in KO2 will be -1/2. Another exception occurs when oxygen is bonded to fluorine. In oxygen difluoride OF2, oxygen is assigned an oxidation number of +2. Similarly, in dioxygen difluoride O2F2, oxygen is assigned an oxidation number of +1. This is because fluorine is more electronegative as compared to oxygen. The oxidation number of hydrogen is +1. Again, you must remember the exception. when hydrogen is bonded to metals in binary compounds. For example, lithium hydride, sodium hydride, calcium hydride, the oxidation number of hydrogen is -1. So take the example of sodium hydride NaH, where sodium has the oxidation number +1 and hydrogen has the oxidation number -1. Very important to remember, in all its compounds, fluorine, which is the most electronegative element, always has an oxidation number of -1. Other halogens, chlorine, bromine and iodine, also have an oxidation number of -1 when they occur as halide ions in their compounds. For example, sodium bromide, NaBr. So sodium will have the oxidation number +1 and bromine will have the oxidation number -1. Now you must remember, chlorine, bromine and iodine, when combined with oxygen in oxoacids and oxoanions, they have positive oxidation numbers. In case of binary compounds of metals and non-metal, oxidation number of the metal is always positive and oxidation number of the non-metal is always negative. Like in NaCl, it is a binary compound of metal and non-metal. So sodium will always have the oxidation number positive. Sodium is +1 oxidation number and chlorine has -1 oxidation number. The algebraic sum of the oxidation number of all atoms in a compound is 0. So we can take any compound. For example, if we take sulfuric acid H2SO4, the algebraic sum of the oxidation number of all atoms in sulfuric acid is 0. In case of polyatomic ions, the algebraic sum of all the oxidation numbers of atoms of the ion is equal to the charge on the ion. So let us take example of sulfate ion, SO4 2-. Here the sum of oxidation number of 4 oxygen atoms and 1 sulfur atom in sulfate ion will be -2. Now let us calculate the oxidation number of sulfur in sodium thiosulfate Na2S2O3. Students, it is very important that you know the correct formula of the compound before you begin to calculate oxidation number of the elements in the compound. So in case of Na2S2O3, as we have studied, sodium is an alkali metal. It will have oxidation number +1. For sulfur, we want to calculate the oxidation number. So we take it as X. Oxygen has the oxidation number -2. So in case of Na2S2O3, for sodium it will be +1 multiplied by 2 as there are 2 sodium atoms. For sulfur, X multiplied by 2 as there are 2 sulfur atoms. And for oxygen, -2 multiplied by 3. So when you solve, you will get X as +2. The oxidation number of sulfur in sodium thiosulfate Na2S2O3 is +2. You can see all the steps of the calculation of oxidation number. Here you can pause the video for a while to see the calculation of steps to determine the oxidation number of sulfur in sodium thiosulfate. Now let us calculate the oxidation number of chlorine in perchlorate ion ClO4 with 1 negative charge. So you can see here, students, we will take chlorine as X, oxygen will be taken as -2 and perchlorate ion has a single negative charge. So X will be chlorine plus -2 into 4. -2 is the oxidation state of oxygen, and there are 4 oxygen atoms which will be equal to -1 now, and you can calculate X as +7. The oxidation state of chlorine in perchlorate ion is +7. Now similarly, try and calculate the oxidation number of sulfur in sulfuric acid yourself. Sulfuric acid is H2SO4. So take hydrogen as +1, take oxygen as -2, and find out the oxidation number of sulfur in sulfuric acid. Upon solving, you will get the oxidation number of sulfur in sulfuric acid +6. Now calculate the oxidation number of manganese in potassium permanganate, which is KMnO4. Take potassium as +1, take manganese as X, take oxygen as -2, and do the calculations yourself. You will get the oxidation number of manganese as +7. Now let us define oxidation and reduction in terms of oxidation number. So oxidation is an increase in the oxidation number of the element, and reduction is a decrease in the oxidation number of the element. So what will be oxidizing agent? It will be a reagent which can increase the oxidation number of an element, and reducing agent will be a reagent which can decrease the oxidation number of elements. So we can redefine redox reactions as reactions which involve change in oxidation number of the interacting species. So in case we have reactions where the oxidation number of the interacting species changes, these reactions will be redox reactions. Let us take an example. The question is to justify that the following reaction is a redox reaction. Iodine plus H2S gives 2Hi plus sulfur. We also need to identify the species oxidized or reduced, and the species which acts as oxidizing agent and which acts as reducing. Let us consider the reaction iodine plus H2S giving you Hi plus sulfur. First of all, we need to balance the equation. So I2 plus H2S gives 2Hi plus sulfur. Determine the oxidation number. So iodine is 0. In case of H2S, H will be +1, sulfur -2. In case of Hi, again H is +1, iodine is -1, and sulfur is 0. So in case of iodine, we see that the oxidation number decreases from 0 to -1. So iodine is undergoing reduction and it is an oxidizing agent. In case of sulfur, we see the oxidation number increases from -2 to 0. So here there is an increase in oxidation number. So sulfur or the sulfide ion undergoes oxidation and it is the reducing agent. I hope the concept of oxidation number is well understood by you. Do like and share the video, subscribe to the channel ChemBank, and press the bell icon for updates. Thank you.